So let's go ahead and output a sequence given an explicit formula. So we are given this explicit formula, a sub n equals 12 times n plus 3, and we're asked to find the 12th term. So let's go ahead and substitute 12 wherever we see an n in this formula. So we got 144 plus 3 is 147. So the 12th term equals 147. Now going down to example 2, we are asked to define the first three terms of a function given the formula a sub n equals 4 plus n minus 1 equals 5. So oftentimes, especially when we get to more complex formulas, I like to write out what we are defining our function or formula to be, and by substituting n into this formula, I have 4 plus 1 minus 1 is 0 times 5. So the first term is 4. For n equals 2, I can go ahead and plug that in. So I have 2 minus 1 times 5, and that equals 9. For 3, if I go ahead and plug in 3, I end up with 14. So I have just defined and calculated out the first three terms of this sequence given the explicit formula. I would like for you to find the 11th term, so go ahead and pause the movie and answer that question. So if you were to plug in 11 for n, a sub 11, I have 4 plus 10 times 5, which is equal to 54. So moving on to example 3, we are actually going to be solving the formula in order to find a sub n, or find a particular term after 36. So the first thing I would do is to find the common difference d. So we're looking at the difference between the terms that we are given, and we see that we have the common difference of 10 in between each of these values. Now, if you look back to your definition of the general pattern, we are going to write the rules as a sub n using the first value. So we have 6 and n minus 1 times d, which is 10. It's always important to know that in this n minus 1, that has to be minus 1, because if we were to put 1 in there and utilize a common difference, we would end up with the first value being 16, and that's what we do not want. So the first term really does dictate this formula, and then we can consider the number of shifts afterwards. There is no shift of 10 into 6 at this point, so we denote this as n minus 1. Another way we can also write this, if we look at the relationship between the term and its value or placement with n, that a sub n can also equal 10 times n minus 4. So I have 40 minus 4. I have 30 minus 4. I have 20 minus 4 and 10 minus 4. So this is another form of how you can write a general pattern for a series that's arithmetic. We won't always have perfect integers when looking at the relationships between numbers. So in this case, we do have some fractions here. And if you look, the first thing you should do is to find that common difference. And I can see that I am adding 0.25 or a quarter to every single one of these values. So my common difference d is 1/4. I'm going to go ahead and apply the rule. A sub n is the first value plus n minus 1 times 1/4. Again, that's the first term plus n minus 1 times the difference or the number of changes that we had between the numbers. We can alternatively write this as 1/4 times n plus 0.75 and we can go ahead and double check our values in the sequence. The way I got 0.75 was recognizing the fact that this rule in particular right here, this latter one here on the bottom, isn't considering the first value a sub 1 in the actual formula. This 0.75 does represent that by saying I do have a quarter difference with 1, and 1 minus the difference, or 1/4, is 0.75. So it may not be directly stated that a sub 1 is represented here, but in this number and what's defined by 0.75, if you take that first value and subtract the difference, so a sub 1 minus d, you will get what we call C for this general form. I would like you to pause the video and solve for letter C. Okay, once you have solved for letter C, we're going to move on to example 4 with defining a recursive formula. So please turn to the page in your book, Writing Recursive Definitions for a Sequence. Okay, so just a reminder, the recursive formula is actually built upon the previous term and the initial value, or the initial number in the sequence. You must utilize both of those two parts to complete a recursive formula definition. So example 4, we're going to look for the simple addition or subtraction patterns between our numbers that are listed here in example A. And we're going to determine the behavior. We've got a sub 1 equals 1, and in between each of these values I see that there is a difference of 3, so my common difference is 3. A sub 1 equals 1 happens to be the first part of my recursive formula definition, and then the general formula for recursiveness is going to take that the term previous and add that common difference of 3. So simply put, these are the pairs of information that define a recursive formula, and this is the answer.